Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of orthographic projection of lines using the software Solid Edge. Coming to the problem statement. A line AB measuring 70 mm as its end A, 15 mm in front of VP and 20 mm above the HP. And the other end B is 60 mm in front of the VP and 50 mm above the HP. Draw the projections of the line and find the apparent and the true inclinations of the line with both the reference planes. So looking at the problem statement, we can tell that the true length of the line is given and that is 70 mm. And also the position of the endpoints of the line AB, that is A and B, is also given, that is 15 mm in front of VP and 20 mm above HP. And the other one is, that is the endpoint B is 60 mm in front of VP and 50 mm above HP. So the true length is given and the location of both the endpoints are given. So keeping this data, now we shall see how to do this projection. So we'll go to the sketching and select the line and begin the problem by drawing the XY line of thickness 0.18 mm. So draw a line of any arbitrary length and annotate this line as X and Y. The principal plane above the XY line is VP and the principal plane below the reference line is HP, that is vertical plane and horizontal plane. So now we will locate the end point A. So we will get back to the line option and select a projection line of thickness 0.13 mm and locate the point A. So it is 15 mm in front of VP and 20 mm above HP. So let me locate the front and the top views of the point A. So this is 15 mm, and let me draw the corresponding locus line of the point A. So this is the locus line of point A in the vertical plane, and this is the locus line of the point A in the horizontal plane. So let me annotate the front view of the line as A dash and the top view of the line as A. And this line is locus of A in the vertical plane, and this line is locus of A in the horizontal plane. So this completes the positioning of the point A. And now he also tells us that the point B. So coming to the point B, he tells that it is 60 mm in front of VP and 50 mm above HP. And also the true length of the line is 70 mm. So but how to measure that distance? The distance between the end projectors is not given. So what I can do is I'll simply select this XY line and try to locate the locus of the point B. So that can be done by selecting the XY line and then offset this XY line to a distance of 60 mm in front of VP. So I need to select this first and then select the offset option and then select this line and enter a distance of 60 mm. So click enter and it is asking in which direction. So this is 60 mm in front of VP and also 50 mm. So for this, again select the offset option. So it is asking which entity should be offset. So click on this XY line and enter the distance as 50 mm and click enter. So it is asking either this direction or this direction. So it is in the vertical plane, so 50 mm above HP. So this is what is the locus of B in both VP and HP. So let us just change the thickness of this line to 0.13. So it is already 0.13. It will take the parameter from the previous settings. So let me annotate this line as locus of the point P in the vertical plane, and this is the locus of B in the horizontal plane. Okay, so now this is done. So we will show this distance also, that is 20 mm above HP and 15 mm in front of VP. So this is the locus of B and this is the position of A. So now we need to draw a line measuring 70 mm in both the planes. So for that, let me select 0.13 mm thickness and a continuous line. So keeping A dash as the center, I need to draw a line of length 70 mm. So that is the true length that is given to me. So I should ensure that this 70 mm is going to touch the locus of B. So it is making an angle of 27 or 25.38 degrees. Approximately it is 25 degrees with respect to the HP. So this is 70 mm. And then it is also making an angle of minus 30 degrees. Okay, so the length should be 70. So minus 40 degrees, or okay, 40 degrees with respect to the VP. So now I can annotate these 2 points as B1 dash and B2. So this is the true length of the line when it is inclined at this particular angle or having its true length as 70 mm. So the true inclinations are 25 and 40. So these are the true inclinations and this is the true length. So we can just measure the true length. So it is 70 mm in both the planes. So now we will follow the procedure to get the apparent views of this particular line. So the first procedure is I'll consider the front view of the line A dash B1 dash when it is inclined at an angle of 25 degrees to the horizontal plane. And now I will rotate this line and make it parallel to the XY line, and I will get the end point B1. So this is the top view of the point B1. Now again I'll be selecting the arc by center point and consider this particular radii of the arc, and then I'll cut an arc to meet the locus of B, and I'll draw the top view of the line, which is having a thickness of 0.50 mm. So this is the point of intersection. So select the line of thickness 0.50 mm and it will be a continuous line. So the point of intersection. So please use the zoom options to ensure the point of intersection is correct. So this is 63.25, which is the apparent length of the line in the top view. And now to draw the apparent length of the line in the front view, I'll select a continuous line of thickness 0.13. So let me draw a perpendicular line from B2, that is I'm rotating the AB2 line, making it parallel to the reference plane, and I'm going to generate its front view in the vertical plane and annotate this point as B2 dash. And now I'll draw an arc of radii A dash B2 dash and intersect that with the locus of B in the vertical plane, so that I will be able to generate the apparent length of the line in the front view. So it should be having a thickness of 0.50 mm. So from A dash to the point of intersection. So this is the front view of the line AB, which is measuring 53.62 mm. So this is B dash. And this point is B. So AB is the apparent length of the line in the top view, and A dash B dash is the apparent length of the line in the front view. So just ensure that the endpoints are visible correctly and they're not intersecting with any of the projection lines. So now let us use the leader option to indicate the directions of the projection lines. So this is the correct direction. And let us measure the apparent inclinations, that is alpha and beta. So alpha is 34 and beta is 45, and theta is 25 and phi is 40 degrees. So with this we have completed the problem. So here, to sum up, in the problem statement the true length of the line was given and the location of the end points of the line was given, that is A and B was given. But however, the true inclination or the apparent inclination or the measurement of the line in its front or the top view was not given to us. Only the true length and the location of the extremities of the line was given. So with this data, we have generated the orthographic projection of the line AB. So with this, we complete the problem.